Hi guys, welcome back to a new video. Today we're gonna go through the electrical system of the Embraer 195, and this electrical system of the aircraft that I fly is a very common one. You could say this is the electrical system of like general airliners. So where does electricity come from? How many generators do we have? How many batteries? How big are those batteries? And what are kind of our redundancies that we have in those aircraft? Because of course, in this system, we do have redundancies as well as with every other system. So let's go straight into it. So let's see what the electrical system of the Embraer or general E-jets looks like. This is a general overview. I'm not really an electrician, so I do not know what all of those things mean, but I do have a general knowledge, of course, of the system. I just wanted to give you this sheet right here. So at the bottom right here, you have your batteries, and this is your DC source, main DC source actually. And on the top you have your generators, which we have a few actually. We have the RAT generator. We will go into detail of all the generators later on in this slideshow. The RAT or Embraer turbine generator is an emergency AC source for our aircraft. The Airbus has it as well, although the Boeing 737 can live without it. Why? Talk about that later. We have the IDG. We got two IDGs connected to the engine. So the general is electric setup on our aircraft is very automatic. We do not switch. Actually, there's only one switch we use all the time during every turnaround. But other than that, we do not touch the electric pattern. We go over that later, even in my simulator here at home, to just show you the general dynamics of it. And the AC and DC systems obviously power almost every aircraft systems like FADEC, the trimmable horizontal stabilizer, fly-by-wire system, which we do have, and obviously the sleds as well, because our sleds are actually powered by electrics. So let's ask the question, where do we get our power from? We do have our main power source, which is the integrated drive generator. This is connected to the engine's gearbox, one on each engine obviously, and it produces 4 kilovolts amps with 150 volts AC, 400 hertz, 3-phase. This is actually for all the generators, even the Embraer turbine, and of course external ground power units as well produce that kind of electricity. Of course, the gearbox has variable speed, and that variable speed, depending on the N1 rotation speed, is then converted to a constant speed via hydromechanical means, kind of like in gearbox, like those weird gearboxes in some automatic transmission cars. I think it's called CVT. I think it's comparable to that actually. And if broken in flight, we can actually still fly. It's a metal release. I think it has to be repaired within 2 days of it being broken, but we can still fly with it. But the APU has to be switched on for us to provide a second a source of AC in case of the other engine failing. Because if we have all AC sources failing at the same time, we're going to look at what happens next. Provided we will fly below 330 and the APU must be available, we can actually fly without one IDG working. So that's that. Obviously, during an engine failure, we also have only one IDG working, and this is actually the reason why we switch on the APU so fast during an engine failure, which also Sully Sullenberger did during his dual engine fail. He switched on the APU right away, which did prevent a lot of systems from going black. So that's actually something that was pretty good. And we do that as well on our non-normal engine failure checklist. We do have the step in which we switch on the APU, which actually does help to have a second AC source, to just be redundant on that. This is called, you know what this is? This is the APU. This is the auxiliary power unit. This is not actually our auxiliary power unit, but this is the most beautiful photo I found. This is a slightly bigger one, but APU does provide us, of course, with bleeder for air conditioning and engine start on ground, and obviously electrics as well. So APU is an electrical gas turbine generator, much like our engines are, so it works on the same principle. We could also fit a diesel generator in there, but it would have probably a different kind of fuel and I don't know why we actually don't fit diesel generators in the back. Maybe they're not reliable enough. Probably they didn't work at high altitudes. That's probably the reason, yeah. But it's a constant APU engine speed. So we don't have an IDG in that APU because obviously the APU constantly works on the same speed, 100% N1. Or there's no N1. I think 100% is just the APU speed. It's also the same 40 kilovolt amps as the IDG, so it provides the same electricity. And of course, air conditioning on ground, and the electrical generation is possible up to 33,000 feet. This is also the reason why we have to stay below flight level 330 in case we fly with one IDG fail. And to start the APU, max altitude is 30,000 feet. So in case you have one IDG failing in flight, you would have to descend below 30,000 feet, start your APU, and then if flight time is sufficient enough, you can climb up again to flight level 330. But you have to make sure the fuel flow, of course, obviously in this case would be a little bit more. APU consumes about 120 kilograms of fuel, so you'd have to look out for that if that is sufficient according to your fuel planning. The APU has about 600 horsepower, and during start the battery 2 powers the start of the APU solely. So the battery is really disconnected from the whole system, and the battery 2 powers the APU alone during APU start with batteries only. If we start the APU with using the batteries, if we don't have any ground power, actually we get a little message, ICAS message, which is saying battery 2 discharging. This is completely normal. So next up is the RAT, the ram air turbine. It's basically a windmill that is only used during emergency cases, and this will deploy automatically if all AC generators fail. So if you have a dual engine failure, there's actually a memory item connected to a dual engine failure, which is fly speed minimum 265 indicated, and pull the RAT manual deploy lever, just to be sure to have it out. But it would actually be coming out automatically. They produce only for like 15 kilovolt amps, so it's a little bit less, but the same 400 hertz and 150 volts. And it has an automatic variable pitch angle. With that pitch angle, it controls its RPM to then supply continuous 14 hertz. And of course, it will also charge the batteries. It is quite loud. It is actually pretty loud in simulator. It is simulated as well. It's really loud. And actually, a friend of mine who lives in Hamburg, they do a lot of testing with the Airbuses, and sometimes he hears that roar of that RAT going on in an A321 or something, and it's pretty loud when they test out that ram air turbine. Our technicians do test the RAT periodically, but I think only on ground is what I think. And upon deployment, it takes about 8 seconds for it to produce electricity. And during that gap, we have the batteries with inverters getting us AC power for our essential systems. And the batteries can power, I think, 10 minutes before they run out of juice. And then the RAT has obviously taken over the job easily already. And as airspeed actually decreases, we have less kilovolt amps supplied by the RAT, and that means that load shedding will be automatically applied by the aircraft. Load shedding means that some electrical systems that are necessarily not required for the job at the moment will be switched off. Of course, something like cabin lights in the back will be switched off that are not essential for flight safety at the moment. And this is actually a photo captured by me a few days ago. This is the RAT door. There's also a sign like stay clear of the door because it's dangerous, as the RAT could deploy at any moment. I did not try it. If we would pull the lever and on ground, it would also deploy, which would be dangerous for ground crew and also a little bit of a hassle to put back in again, call it maintenance, and it would be probably pretty embarrassing. So I did not do that for you guys, but I had the photo captured for you. Let's continue. Ground power unit. This is the probably main electrical source of energy when we are on the ground. APU does consume quite a lot of fuel, so that is what we use when it's not hot and we do not require any air conditioning. So it produces 114 volts and 400 hertz. Again, same as all the other generators. And we do have, there's an option for another ground power receptacle. Usually ground powers are AC, usually for the big aircraft, but there is a variant of the Embraer 195. It's called the Lineage 1000. It's a business jet variant of the Embraer E195. And on smaller airfields, you might do not find the AC ground power, the big one, the big diesel generators. For that, we have a 28-volt DC socket located usually in the back of the aircraft. And this is only for APU start. But on our aircraft, it's not fitted, as we do not need it. We are usually on the very, very big airports where they do have AC ground power. This is what the ground power looks like in Vienna, a normal unit. This is actually produced in Austria, I think, yeah. Don't know. And this is the display for it. Like you see, 115 volts. They see the fuel consumption. I think it's about 30 liters an hour, so it's a lot less than the APU, which consumes about 120 liters or kilograms an hour with the air conditioning running. Without the air conditioning running, you'll be looking at, I think, 80 kilograms an hour, so a lot less, but still more than double that of the ground power unit. This is the receptacle for the ground power system. It's connected on the left-hand side, on the captain's sides, so right below the captain's window it is. This is where I plug in the ground power. Above that is the steering control switch for the ground crew in case of pushback. So this steering control switch will disengage the steering motor of our nose wheel. So let's go to the DC sources. Mainly the batteries, actually. It's nickel-cadmium batteries, 22 volts, 27 amp hour batteries. It's actually quite small. Even combining the two batteries, 27 amp hours, it's still less than in your car. So it's very small batteries, actually. It's only for emergency use and for startup. Any AC source will provide charging, and without Embraer turbine in that small 8-second window where it's still deploying but not yet ready to produce electricity, we'll have about 10 minutes of battery only mode. And this is also in case of the RAT fails completely to deploy. We do have 10 minutes of essential loads. And this is also important for emergency evacuation, because in case of an emergency evacuation right after engine fire or something, we do not use the APU. We shut the aircraft down completely, and the aircraft is almost completely pitch black. Only the display unit 2 and display unit 3 will be on, and we can emergency evacuate emergency evacuate via the batteries. Also, if we have a ground power failure, but we do leave the aircraft switched on, because in our company it's actually there's actually the rule to have an aircraft switched on in case a different crew will take up the aircraft within less than 3 hours. So if we go on block at like 1 in the afternoon and another crew will come again like 2 hours later, we'll have the aircraft switched on with the power on parking. Power on parking means we have the batteries and the emergency lights switched off. And the reason for that is if we have power on parking with the battery switched on and the GPU fails, then the batteries will be discharging, obviously without any GPU, and also there will be a horn for the ground personnel if the batteries are on without the GPU for more than 5 minutes. So there will be kind of a horn or kind of a honk, whatever. I didn't hear that yet, but it happens. Not to us, obviously. And this is the checklist, and we have the power up checklist right here. And you see that in the power up checklist, we have battery 1 on auto, battery 1 on, battery 2 auto, and we have the battery voltage is checked, because we can only check the battery voltage, which should be minimum of 22 volts, when the AC bus is not connected yet to the aircraft. So we check the battery voltage before we connect the AC ground power unit or switch on the APU, because otherwise we will have a charging voltage, and this is obviously much more like 28 volts. So these are the fly-by-wire backup batteries. We have that in case of a loss of complete electrical power in even a Embraer turbine, and it keeps only the elevator, which is fly-by-wire, and the rudder, which is also fly-by-wire, operating for 15 minutes. The only thing which is not fly-by-wire on our aircraft is the ailerons. This is why it's not operated by fly-by-wire batteries, because in our Embraer 195 the ailerons are not fly-by-wire. although on the Embraer E195 E2 variants, it is fly-by-wire, and you see the difference during landing. Much like on the A320, when the Embraer E195 E2, a much newer variant, is landing, the ground spoilers will deploy, and also the ailerons will deploy and upward as well to help decelerating the aircraft. There's also internal heater and a built-in test, and it's constantly charged by the DC Essential Bus 3, just to be sure it's always fully charged. But this is really something that probably never ever happens. So you would have to be failing the all the two generators, all the two engines, and then RUT doesn't deploy, which usually obviously it's very well maintained and tested. And then the batteries will also not work. You would have to fly by wire batteries. That's something that is very, very rare, and I think probably has never happened before. Some more infos. This is going really deep into the technical stuff, which I don't know too much about, but we do have an integrated control center. This is in the forward and mid avionics bay, with also easy maintenance for the maintenance guys, because most of them are line replaceable units, which means that you have units that may be broken due to a fault, and then you take them out and put back a new one in like 5 minutes, and then it's good to go again. And the old unit you will send into Embraer, or even our guys will fix them, and then they are ready to be taken onto the aircraft again. That's a very easy maintenance that Embraer does. And then also we have a static inverter for DC to AC. It's much like you would find on your car, or you would have on your car if you want to charge something, or if you want to charge something with 220 volts. You would have a inverter like this. We also have it in a forward eBay. It converts 28 volts DC to 115 volts AC, and it powers a standby AC bus when AC power is not available. And during the RUT deployment, which takes 8 seconds, batteries bridge that with the inverter to have AC power as well, not only DC power. Transformer rectifier units is the exact opposite. We will go from AC to DC. We have 3 of those because it's actually constantly used, and it is used because batteries do not actually supply any electricity during normal operation when AC generators are running. There's also the no brake power transfer, which it's actually something that the Airbus does not has, and it is a seamless power transfer from one AC source to another. So in the Airbus, when you have a startup for an engine, you will usually hear a big click with the lights flashing, and this is not something we do have on our Embraer. It's a seamless power transfer from one phase to another, so it's really nice at that. And in case of abnormal operation, the brake power transfer is performed to have a higher speed to change from one energy source to the other. This is our electrical panel, and we will go into more detail on this electrical panel on the real Embraer here on my simulator. So, okay, this is the Embraer 195 on my simulator. It is cold and dark at the moment, so much like you would find it on a night stop or something. Going up to our overhead panel, and this is where the good stuff happens, really. This is the electric panel, so it's actually very, very small. It's not much to switch. I did not use those buttons yet, those 3 in a normal operation, of course, on a simulator, and this as well. This is the IDG we talked about. You can disconnect the IDG right here, but you can't reconnect the IDG when airborne. That has to be performed by maintenance personnel, although you can switch off the IDG, but if you would switch it to the disconnected position, it will not be able to connect again during flight. This has to be performed by maintenance personnel. So switch on the battery 1 and battery 2, and you see that only display 2 and display unit 3 will be powered up. This is on purpose. This is the electrical emergency mode, and you don't want to have any more displays than those 2 powered up. In case another display is powered up, the aircraft must not be dispatched. This is actually in the checklist as well, so there is something wrong with the system. We have flap setting. That's wrong as well. Why is there a flap setting? Are we clean? We are clean, yeah. Okay, so this is what it should look like. We have ICAS messages, and we check the battery voltage at this moment. It should actually be more like 22 volts. Like 27 is a little bit too much, but this is system behavior, weird system behavior of that simulator. We do not have a ground power. We do have one now. And if we switch on the ground power, we go to the ICAS, like go to the electrical display. This is it. You see all the AC buses being not powered at the moment of obviously without a ground power. Then the ground power needs some time to supply voltage. Actually, even if you don't have the ground power connected, you should be able to see the volt, the hertz, and the kilovolt amps. Just connect the ground power right now with the use of that button. And this is the only button we use to turn around. No other button is being used. So now we see the volts, the kilowatt amps, and the hertz, which looks perfectly good. And we have all the AC buses connected. That's good. And this is basically it with the overhead panel. You do have, of course, some more buttons that you will use during an emergency handlings, like switching on or off the TRU. This is mostly used during electrical failures when the TRU is faulty, or during even a fire. You would be using those buttons as well, because you might suppose that a fire is originating from the electricity. But as of now, this looks pretty nice. And obviously, if we start the APU, just start right here, we have a second source of electricity coming up here, and the Embraer turbine would be displayed right here. Maybe if we can we deploy it? Yeah, we can. Look, there's the red. But this is faulty. We're here with 0 airspeed and the red deploys, and we have immediately 115 volts. But maybe we do see the red. Do we see it? Yeah, we do. This is amazing. But it does not rotate, and it shouldn't be rotating because obviously we are on the ground. It would be weird if it would rotate. And now we did a mistake of deploying the red on the ground, which was of course not good. And we would have to, if we would close it again, it should not be. Oh, it's gone. There's no option to retract the red again. So if we once do this one, deploying the red, this will stay outside for as long as there is no technician around. Now we have the APU, and another interesting fact, the logic of the aircraft is if there is engine generators available, the aircraft will be powered by the engine generators, if there's both available. If there is an APU available, it will be powered by the APU generator, and if there's only AC available, obviously powered by the AC ground power unit. So let's switch off this button. There we go, and now we have power from the APU. We can disconnect the ground power. This is how it works, basically. Yeah. Obviously, we also have circuit breakers. We do have two kinds of circuit breakers. We have remote CBs. Those are controlled by the MCDU, only by maintenance personnel. Obviously, we can look at the CB page to look if any circuit breakers are popped out. Maybe the APU is inoperative. Then there is a message on the ICAS which is called CB trip. And this is normal. This just tells us that there is a CB tripped due to maybe a faulty APU or something. And other CBs are in the cockpit or avionics bay, and CBs can be used for reset. So if a full system is faulty or computer has any kind of problem, we can use the CBs in accordance with our QRH and obviously our maintenance personnel to reset a system, much like you do when you have a problem with your computer. You switch it on and switch it off again. This is something we regularly do. And this is the CB page on the MCDU. This is a perfect condition. No CB out and locked. So this is it. This is the end of the slideshow. It's really Embraer systems. We're going to steps into Embraer systems, but really this is not very different on other aircraft, I assume. Some aircraft do not have ram air turbines like the Boeing 737. The reason for that is that Boeing 737 can be flown without any electricity, as it is a fly-by cable aircraft, so traditionally connected with the yoke and the flight controls. So it's called manual reversion. I'm not really sure about any details of that. So they do not require a ram air turbine, actually. Some interesting fact. But we do have one, and Airbus does one have as well. All right, that's it with the show. I hope you found it interesting, and I see you in the next one. Any recommendations about a new topic in the next video, write it down in the comments below. So see you here.